My name is Sheehan. Um, I'm the director of solutions architecture at Crosswalk Labs. Um, I've been a consumer of open data, I'd say for my whole career. I'm just kind of amazed how big this event has become and how like a testament to all the people that organize it. Um, and I've been working in a couple roles. So prior to Crosswalk Labs, I was at AWS supporting NOAA, US Patent and Trademark Office, some EPA work as well. And before that, I was doing geospatial analysis, at equities research at UBS. And then I've also worked in epidemiology at Columbia University, in addition to Oregon Carter or a couple other places here in New York. Um, and I'm here to give a talk titled How Crosswalk Labs Maps Nationwide Neighborhood Level CO2 Emissions Data and then benchmarks to New York City building energy and water data. And that title is a little loose. We'll see uh, what I'll talk about later. Like we're trying to build a building level emissions model across the US. So you can basically find any building emissions or any other asset, including road segments and other types of assets. I saw a prominent climate scientist in James Hansen speak. This is like a gazillion years ago when I was in grad school. He mentioned something about excessive acronyms and abbreviations, inside terms, kind of detracting from intelligent conversations. So I'm actually going to first go through a bunch of key terms before diving into the deeper parts of this talk, just to kind of level set. There's a ridiculous amount of acronyms, and I want to kind of demystify some of them. Can I go to the next slide? I'll say slide. So I'm a member of Crosswalk Labs. We provide national CO2 emissions estimates across the US, and we provide both open as well as commercial data. We have a sort of best in class, atmospherically verified, bottom up emissions data. Slide. We currently model CO2 emissions nationally. We currently model CO2 emissions at the census block group geography. That's our sort of finest unit right now. And here's a view of New York City, and you can see emission data. We have data going back to 2010. It's a little small for some of you in the back there. Small for me right here. 2010 to 2023. And so we have that sort of geographic granularity that block grew. And we're starting to increase the spatial and temporal granularity of our data offering and our UI. So we'll be able to zoom in on a single asset like a building or a street segment. And as we see in the later slides, we're going to get into the discipline of building level energy and building level energy estimations. Next slide, please. So bottom up emit. Oh, sorry, I skipped one there. Okay, next slide. So bottom up emissions modeling involves collecting detailed information on specific emission sources. So it might be anything from a vehicle or an industrial process or building, and then calculating emissions based on activity data and emissions factors. This is what Crosswalk Labs does. With bottom up, you have the source asset, building, power plant, road segment. With some activity, we model the emissions for that particular location. Either it could be a linear asset or an area as well. Next slide, please. Top-down emissions. This is another sort of modeling or observational method. This estimates emissions based on broader indicators such as atmospheric measurements or economic data. And then you actually have to attribute it to the source in the case of top-down. So here, think of like remote sensing, satellite observation, or aircraft remote sensing. So top-down emissions can show you both the anthropogenic emissions plus the more naturally occurring atmospheric chemistry. But then we lose that ability with top-down. We lose the ability to tie to observed emissions to actual locations or assets. So this is where that's sort of the weakness of top-down. Next slide, please. So I'm a visual learner. I like this diagram. So this is from the Stanford University of Earth Sciences. And so tying top-down emissions to activity or emitter involves more steps and processes. The bottom up, you know this source information. So I want to reiterate that for the further discussion. So we work with the bottom up. You might see other providers that do remote sensing based emissions modeling. Again, attributing to that source is a bit of a challenge. And then next, I'm going to move on to New York City and their very progressive laws around building emissions. But first, I'm going to cover a couple other terms to level set everyone's knowledge. Slide, please. So, emissions inventory, according to the EPA, an emissions inventory is roughly a comprehensive database that quantifies the amount of specific pollutants released into the atmosphere from various sources or sectors within a defined area and time period. Next slide, please. Scope 1 emissions are direct greenhouse gas emissions from sources that an organization owns or controls, such as an on-site fuel combustion or an organization's vehicles. Next slide, please. Sorry, there's a lot of slides. I'm unfortunately keeping you busy here. Scope 2 emissions are indirect emissions from generation of purchased electricity by the reporting organization. So when we think about like a building, if you have a burner, like a fuel burner in your building that burns, maybe it burns natural gas, maybe it burns fuel oil number 4 or 6, that will be considered the scope 1. If you have like electric heating or your electricity, that would be considered your scope 2 emissions. Next slide, please. And then scope 3 emissions encompasses all other indirect emissions that occur in the value chain of the reporting organization. This includes both upstream and downstream activities. Scope 3 is like really the hardest one to actually deal with. They're all fairly hard. Scope 1 probably. Scope 2, fairly easy. Scope 1 can be difficult to some degree. Scope 3 is like very, very hard to do, especially if you have a large organization. Next slide, please. So New York City in 2009 created a groundbreaking law called Local Law 84. And this requires buildings to submit annual energy use benchmarks. So roughly speaking, covered buildings are buildings that exceed 25,000 square feet. These buildings are required to report energy use data and their emissions. Next slide, please. And then I think there's 1 or 2 chairs over there too. There's also chairs over here too. Okay. Lost that spot over there. So Local Law 97. Okay. Local Law 97 requires the covered buildings to actually reduce their greenhouse gas emissions. So 84 mandates the reporting. Local Law 97 of 2019 mandates reduction in emissions. So under this groundbreaking law, most buildings over 25,000 square feet are required to meet new GHG limits beginning in 2024, with stricter limits coming into effect in 2030. And the goal, again, is to reduce emissions produced by the city's largest buildings by 40% by 2030, and then absolute net zero by 2050. Next slide, please. And according to New York City, about 2/3 of greenhouse gases emissions come from buildings. Next slide, please. And then Crosswalk Labs, we actually estimate around 45% of scope 1 CO2 emissions come from buildings. I'd like to dive a little bit deeper into Local Law 97 when they say that. I'm not sure what their methodology is exactly, whether they break out scope 1 and scope 2, or we're just looking at CO2, we're looking at methane and other gases. So one thing you'll find if you do emissions inventory is like there are very standard methodologies, and that kind of discrepancy is fairly common. But for now, let's say 55% or 50% of the buildings, we take the mean. So we could say that buildings make up a significant amount or the majority amount of emissions in New York City. Okay, next slide. Just to get a quick baseline of where everyone's at in the room, by show of hands or a thumbs up, yay, nay, how many of you have heard of Local Law 84 or Local Law 97? Nay. Oh, awesome. This is great. Okay, great. Well, I guess Open Data Conference, like people a little bit more civically engaged, because I didn't think it was that many folks. Great. And then how many of you have heard of the term scope 1, 2, and 3 emissions? Okay, great. Well, maybe there's a bit of a selection bias also because you're coming to the emissions talk. And then how many of you have ever worked on an emissions inventory? No. Okay. Okay. Cool. Cool. These are a rare breed of folks, and it's quite painful for some of the people that are collecting all that data. Next slide, please. So we've already done an introduction. We've talked about some of the key terms. We ran a little kind of poll. Next, I'm going to talk about introduction of how we model emissions. We're going to go a little bit deeper into Crosswalk Labs. Talk about open data in our pipeline. Open data is our fuel for everything that we do. On roads, vehicle emissions modeling, so just vehicular traffic, and then talk about airports, and then we'll talk more about buildings, and then how local law 84 and 97, how they sort of help what we do, and just some interesting statistics to kind of show that the coverage of the law. Next slide there. So founded in 2021, Crosswalk Labs collaborates with various organizations, including the Data Foundation and Climate Mayors. And we provide open access to emissions data for every neighborhood in the US. Our small team comprises of experts in environmental science, data analysis, and policy. And we work to support effective climate mitigation decisions and inventory reporting. This information assists cities and states and some federal agencies in making informed decisions regarding climate action and policy implementation. Next slide. Our mission is to make every decision a climate decision. We provide reliable and timely information on greenhouse gas emissions. Next slide, please. And we have a bunch of different partners that help us sort of move the needle on this bottom-up emissions modeling and reporting. Our company was founded from a combination of academia and federal agencies. So we have roots at NIST and EPA. Our founders, Jason Burnett and Phil DeCola, come from EPA and the White House Office of Science and Technology, respectively. Next slide, please. And then with the utmost gratitude towards the Data Foundation, I always call them Open Data Foundation, but their logo is right there. The Data Foundation champions the use of open data and evidence-informed public policy to make democratic society better for everyone. So they're sort of like the data in NYC, but for like the federal government's data. So they helped us support our open.crosswalk.io. That's our open data platform. And so here's a quick view of New York City's emissions again, and we can pan and zoom and select emissions for different sectors and years. Next slide, please. And then the tool allows for download. So you can download our data at the US Census tract level, I think state and county as well. So you just go up to the right-hand corner. We just have a little button there that's kind of hard to find. Next slide, please. And then next I'll talk about Crosswalk application for climate mayors. Next slide. All members of climate mayors have free access to Crosswalk Labs. So if you work for any like city agency or town agency or anything like that, any sort of mayor's office, or you work in a city or a town with a mayor and they're part of the Climate Mayors Network, you have access to Crosswalk Labs data. There's a little bit more granularity than the open data offering right now. Open data is tracked. Climate Mayors is census block group. And we're going to increase the resolution for publications soon as well. So next slide, please. So Crosswalk modeled emissions data. Again, we can kind of explore it in the web application. This isn't showing going all the way back to 2019. You can click on the different sectors, and then we can export the data to use Excel or GIS software or anything like that. Okay, next slide, please. Great. So we're going to talk about emissions sectors real quickly, and then we're going to do a bit of a deeper dive into some of the sectors. So next slide, please. So we have airport emissions. So this includes emissions modeled from aircraft activity at airports. Then we have on-road vehicle emissions, and that's modeled from vehicle miles traveled or VMT. And our source for that actually is GPS data from vehicle activity. There's a commercial provider that created a data set that allows us to kind of have estimates of VMT across every road segment. And then power plants, which are usually our largest emitters for industrial type facilities. And these publish have to are sort of mandatory reporting to the EPA. They have to be published in open formats. And then mobile equipment, which is vehicles that don't traditionally operate on roads. So mobile is like off-road vehicles, lawnmowers, things like that. Next slide, please. And then for buildings, we do commercial, residential, and industrial. We model emissions for buildings. Next slide, please. And then the last scope 1 sector is emissions from passenger and freight trains and the commercial marine vessels. And so we only go out as far as, I think, like the county boundary that goes out into the ocean for those commercial marine vessels. And then scope 2, those are our emissions that are indirect greenhouse gas emissions associated with consumed electricity. We include scope 2 for different building types, so residential, commercial, and industrial. So one thing to be careful for in scope 2 emissions is if you are doing a emissions inventory, for example, like let's just say New York City, and there is a power plant that's like burning coal or something. I don't think there's any of those anymore, but let's just say, for example, and it's burning coal. You have to be careful in that is a scope 1 emission, but then if we draw that emission in to our building and then we report the scope 2 for all the buildings, we'd be essentially double counting that emission. So one has to be somewhat careful in, if the scope 2, if you're consuming electricity that's in your district and you're a climate mayor, for example, you'd be sort of double counting if you're including a scope 2 and scope 1. And sometimes scope 1 will happen in a different area and you draw that energy, those electrons in. So it gets a little complicated sometimes, or some folks will double count or fail to count for scope 2, for example. Next slide, please. So open data in our platform, as we are at an open data conference, it is important to mention that our national uniform bottom-up emissions modeling requires the ingestion of many national data sets. I think we're at like 50 to 60, it might be more than that. I'll mention a few. So one is the U.S. Environmental Protection Agency, EPA, the Greenhouse Gas Reporting Program, more commonly known as GHGRP. We also have the EPA EnviroFacts. We have the U.S. Energy Information Administration, commonly known as the EIA, the State Energy Data System, also known as SEDS, the U.S. Federal Aviation Administration, or FAA, Traffic Flow Management System Counts Data, TFMSC, and then scores and scores more. I mean, it is, looking at our documentation and stuff, is I've worked there now for a year at Crosswalk. I open the documentation sometimes and I'm like, what is this acronym? So we have probably 100 different acronyms for data sets and different agencies. Next slide, please. And so here is a high-level architecture of our platform. So at the top, we ingest our open data as well as some commercial data sets. And then we run transformations and then onboard that data to prepare that data for analysis-ready modeling. So we try to do like serverless compute. We try to use things that kind of scale down and scale up, cloud-native data storage on Amazon S3. Next slide, please. And then we perform our bottom-up emissions modeling for all states across years. So we spin up our infrastructure and then spin it down. We have our sort of output there. And then next slide. And then we publish our data to a Postgres database and serve out the data for users. We're also working right now, we've been experimenting with PM tiles. So if anyone in the audience has used PM tiles, Protomaps tiles, awesome. I'll probably ask you your experience there. So if anybody has experience with that, I'd love to learn more. We're finding the performance to be awesome, and yeah, we're really excited for that sort of read-only data service. So next slide, please. Okay. So now we're going to talk more specifically about on-road vehicles and airport emissions. Next slide, please. So when modeling emissions for on-road vehicles, we start with some activity data. Next slide, please. Sorry, I always have a lot of slides. I like to keep things moving, so that's on the next slides here. So let's take a look at what this looks like on a map. And this is our H3 grid. We first see, it's very quick, the total emissions. Hold on, let's wait for it to come back up here. Yeah, there we go. Sorry, I didn't let it wait for it to record. So we'll see the total emissions at first, and then this is the vehicle emissions. And we can kind of almost see, like we have Belt Parkway, we have like the BQE, the Verrazano Bridge and everything. So, you can kind of see like where all that sort of vehicle related emissions. I mean, Manhattan is just a mess there. Next slide, please. And so we have a commercial data provider that provides the vehicle miles traveled for every street segment in the lower 48. And then we use the Federal Highway Administration, or FHWA, Highway Performance Monitoring System, HPMS. We use their average annual daily traffic, the ADT, for Alaska and Hawaii. And so with this data, we have vehicle miles traveled, or VMT, for every road segment. Next slide, please. And then this visualization kind of shows us, kind of zoom in here, the darker red is higher values, and then we actually see through the size or the width of the segments on the how much larger, how much more VMT there is on our highways, our more highly trafficked corridors there. Okay, next slide, please. Now, each vehicle type will use different fuel types and have different emissions. So from the Federal Highway, the FHWA, we get statistics about different vehicle type percentages for urban, rural, interstate, arterial road classifications. And we estimate what amount of VMT, vehicle miles traveled, is attributed to what vehicle types on what roads, because we don't get actual vehicle types from our GPS VMT provider. Next slide, please. And so here's like some of the tables that our friends at FHWA publish. These are just percentages for different types of road classifications. So think about a road outside, hypothetically, like the road that's right here could have maybe 10% combination truck. And that's like a big rig. 10% single unit truck. It's like a bigger box truck. 10% bus traffic, maybe 20% light trucks, smaller trucks, and then maybe 45% passenger cars and 5% motorcycles. So each of these vehicles are going to use different types of fuel, and they're going to generate different types of emissions. So these are generated at the state level, so they have different breakdowns, and so we do downscaling, so that there is a bit of a limitation when doing this. So let me think of a use case. Like if you have a distribution center or more like some sort of heavily trafficked location, currently right now it's a limitation that we have. We don't have that sort of like granular street level vehicle traffic percentage makeup. Hopefully we'll get there soon, but we don't have a good data set for that right now. Next slide, please. Okay, and then we use this transportation energy data book. It's literally a textbook, and it has different fuel types and what percentage of passenger cars are diesel versus gasoline and things like that. When they said it was a transportation energy data book, I was like, is that like a slang for something? They were like, no, it's like actually like an old textbook with different types of vehicle things. So we had to like digitize all the or tables and everything. Next slide, please. Then we have a couple different other sources. U.S. Census block data just to delineate the urban versus rural segments, streets, things like that. So next slide, please. Okay. Okay, so here we have the emissions by vehicle type in downtown Chicago. So in this visualization, the lighter yellow and orange are higher volumes of CO2, and then the darker purple are lower. So we could see trucks in the first two visualizations here, and trucks and passenger cars kind of dominate. It's a little bit pixelated, but dominate the emissions that are generated by each vehicle type. The motorcycles is probably the lowest there. Next slide, please. And when that sum of emissions by vehicle type per road segment, when we sum all that up, in this example here in New York, we could see like this thicker, more bluish roads having higher CO2 emissions, whereas the lighter yellow to green segments, these local roads have much lower emissions. And in this case, we can really see again the difference between the highway and more highly trafficked street segments versus those local roads. Next slide. Okay, and then we'll quickly go over another sector. Airport emissions are from aircraft takeoff and landing operations. And let's take a look at what this looks like on a map. Next slide, please. So here's our H3 grid. And again, I didn't give you enough time to actually see the total. There's the total. And then these are just the emissions when we filtered for airports on the right-hand side there. So we have JFK, LaGuardia, and then a couple of these like helipads and things. And then obviously outside New York and New Jersey there. Again, for other airport related emissions, like the building emissions or their non-road vehicles, such as the aircraft tugs. I didn't know what those things used to be called. They're called tugs. Aircraft tugs. Those will be included actually in other sectors. They will be attributed to this railroad sector. Next slide, please. And then we scrape the FAA Traffic Flow Management System Counts data, the TFMSC data. This is hourly takeoff and landings at large U.S. airports by aircraft type. Next slide, please. Actually, this data, it's like I think it's like a job application. So we actually have to scrape it with a headless browser, which is really annoying to have to do because you have to like program each of the button interactions. We use Chromium for that if anyone is ever interested in scraping data with a headless browser. So this is a visualization of some takeoffs and landings. We only attribute the emissions under 3,000 feet. So an airport, when they do their emissions inventory, they're only sort of responsible for emissions in takeoff and landing below 3,000 feet. And this is the choice that's been outlined by the Tier 2 airport methodology from the IPCC. IPCC is the Intergovernmental Panel on Climate Change, which is an intergovernmental body of the United Nations. And then, so for example, we know how many Airbus 320s will land or take off at JFK for every hour of every day. Next slide, please. Smaller airports, we use this thing called 5010. It doesn't have the aircraft type. So we have less granular information about those types of aircraft. Next slide, please. And then the IPCC has emissions factors for each types of aircraft. So we use that when we have that information. And then in the absence, next slide, please. In the absence of granular aircraft types, if we have more generic information, we use the emission factors from the EPA. Okay, slide. And so here we have Phoenix, for example. In 2023, we see just over 1 million metric tons of CO2 emitted at the airports for takeoff and landings within that administrative area. You can also see there's some airports outside towards Mesa and Gilbert. So this is a good view. Someone in the Phoenix sustainability team, if they want to do their inventory for airports, what we've done here is we've removed some of that manual data collection effort. So imagine all those cities, all those counties, all those towns doing the same exact data collection effort. We're trying to automate that so that those folks have both a uniform apples to apples comparison of climate emissions data, but then also to save them time because it's not useful for all of them to do the same sort of ETL or scraping all that data. It's not very helpful for folks. Next slide. Okay, so now you have a basic understanding of how we do on-roads and airport sector modeling. Let's talk more about our building emissions modeling. So we currently use EPA, National Emissions Inventory, which is the NEI. Again, I said there's going to be a lot of acronyms. Non-point emissions, which are county estimates. And then by building type, either commercial, residential, or industrial, we downscale emissions weighted by the building area square footage as provided by the National Structure Inventory, NSI, by the U.S. Army Corps of Engineers. So we're consuming all this. I want to emphasize all this open data goes into our recipe here. So what we've been working on is a statistical model to estimate building energy use and emissions for every single building in the US. Next slide, please. So here's a screen recording of what we've been working on. This is actually the PM tiles I was talking about for rendering buildings and serving out data on S3. PM tiles, if you haven't heard of it or worked with it, check it out. It's a really cool open source project that relies on RAID requests of objects stored on cloud storage. And if you're not having a transactional database, it's like really powerful for being able to serve out lots of data rather quickly. So this application allows us to dive into individual buildings and explore emissions and inputs to the statistical model to generate emissions estimates. So let's say we start with some physical characteristics, such as like square footage. A lot of times in both the physical and statistical modeling of building energy and emissions calculations, square footage is like a big driver. The activity also is a big driver as well, but square footage is kind of like you need that value there. And then activity characteristics such as the NAICS or SIC codes. We can have some descriptive information as well. But a NAICS code is the North American Industry Classification. I forgot what the S stands for. And then the SIC, which is kind of fallen, is less used now, but it was the Standard Industry Classification Code, which sort of tells you what's going on at a business or a building. And this helps determine the energy use intensity or the EUI. And so like you have a hospital, for example, you have a really high EUI, right? Because there's a lot of things plugged into the wall, a lot of electricity consumption, heating, cooling. And then let's say you have a warehouse that's like not refrigerated or anything, it'll have a bit of a lower EUI. And so we've actually already collected now 500,000 publicly available individual building energy benchmarking data points. And we are iterating on different models that allow us to use benchmarking data to help construct this statistical model. So imagine you have all these different variables, and then your target variable is either energy use or emissions. And we basically train that model and then deploy it to do testing. We're like actively working on this. So there's about 64 US cities that are currently providing benchmarking data. And we have about half of those ingested. And we're like totally grateful for these cities publishing this as open data. And then if they're not open data, like some of them have mapping portals, then we actually have to like scrape those. Yeah, quite annoying. We're semi grateful for those. Next slide, please. Okay, so now we get to New York City. Back to New York City here. Local Law 84, the New York City benchmarking law of 2009, requires buildings to annually assess the efficiency of the building's energy and water consumption. The covered buildings include buildings that exceed 25,000 square feet, or if there's two or more buildings on the same tax lot that together exceed 100,000 gross square feet. I realize this is the right audience for like this minutia, the covered buildings list. A lot of my coworkers don't live or work in New York. Explaining like bins versus BBLs to them, it's like I'm speaking another language. Two or more buildings held in a condominium that form an ownership that are governed by the same board of managers and that together exceed 100,000 gross square feet, or a city building. So there's a couple different types of classifications. Just generally, we think local 84 or 97, 25,000 gross square feet. There are some exceptions. I think the Port Authority, I think there's some agencies that don't have to report. I can't remember all of them, but they can have a building over 25,000 square feet and not report. Next slide, please. And then here's the data from Local Law 84 published on NYC Open Data. So this is like in the movie, if you ever see a movie and then they say the title of the movie and the dialogue, this is that kind of that moment there. So we have the data in Open Data. It was great. Next slide, please. And then there's also a map that's served out by the NYU Marin Institute of Urban Management, Civic Analytics Program, and Urban Intelligence Lab. Is anyone familiar with that group? Is anyone part of that group?
I used to, Brad, research.
Oh, excellent. Yeah. And then in partnership with the Mayor's Office of Climate and Environmental Justice, this is an awesome application. And And so they actually take the energy and water performance data and then provide this interactive map. And you can query the platform to kind of better understand energy and water efficiency, carbon emissions intensity of almost 30,000 of the largest buildings in New York. The open data, is this pull in directly from the API and open data platform, you know?
I don't know the close from the API, but definitely from the base.
Yeah, okay. Would you have to do a lot of cleaning?
Yeah.
Yeah, okay. If you want to go back one slide real quick. One thing, oh, it's not even on this visualization. Oh yeah, it is here. There's like dashes and stuff and different delimiter. Like sometimes they report a BBL with like dashes and there's different delimiters and for different records and stuff. The lineage of this data is such that a building manager or owner puts the data into Energy Star Portfolio Manager for their own sort of like management data. Then they have to like export it out to some format, and then they have to upload it. You might have to correct me. Upload it through this thing called Beam up to NYC, and then it gets published out here. And it's just there's a lot of steps that goes from like the person actually typing the information in the Energy Star Building Manager. And so at some point it'd be nice to visit that. We like either the open data community or somebody kind of clean up that whole process. It's quite involved. And so next slide here. And then I think this is it. Yeah. So we take a look at this one particular building. We can see that it has a greenhouse gas emissions in kilograms of CO2 per feet. So it has 4.46 kilograms per square foot. Next slide, please. And if we look at the Crosswalk Labs asset emissions model right now, this is our sort of naive model, but not bad. It has 4.13 kilograms of CO2 per square foot. And this is a result of our first sort of simple downscaled model. So it's not even a statistical model yet. I was hoping to share more results in the presentation, but the team working on that right now is still kind of in the process, and we actually don't have results. Next slide, please. So those are pretty close. What's interesting about this particular building that I find is like, not just during COVID, but the year leading into and after COVID, we saw a lot lower emissions. I'm guessing either like occupancy went down or something was going on there. That's sort of an interesting data point. And so since local law requires reporting, you might ask, like, why are we doing this? Like, why are we estimating emissions across the country when buildings are reporting? Well, quite simply, only 3% of tax lots in New York City are actually covered by local law 84. Next slide, please. So 97%, and this probably doesn't do that good of a job of explaining because these are tax lots instead of the buildings. And they're going to be a lot larger than the buildings. But so 97% of all tax lots in New York City are not required to report emissions. So like everything that you see with it's sort of not covered, except for the parks and things like that. Any sort of parcel that has a building that you don't see highlighted here is essentially not covered by local I-84. They don't have to report. So if you live in a smaller residential building, you don't have to report your emissions. Okay, next slide, please. All right. Thank you all for bearing with me. We're getting on to local law 97. It's appropriate that we're in the CUNY Law Center here. We're talking about all these foreign laws. So while 84 mandates the buildings to report, local law 97, most buildings over that 25,000 square foot threshold are required to meet the greenhouse gas emissions limit beginning in 2024, with stricter limits in 2030. And then the goal is by 2030 to have the city's largest buildings reduce their their emissions by 40%. And then the ambitiousness of this goal is to be net zero by 2050. Next slide. Okay, this is the Building Energy Exchange created Local Law 97 carbon emissions calculator. This is a really handy tool for, like, let's say you're the building owner and you want to see like what your penalties are going to be. Again, this is all, there's all these amazing tools, but they're all kind of scattered around. So this calculator allows us to estimate a building's carbon penalty as a result of the law. So we'll take this building as an example. So this line is the sort of threshold. This is the carbon below threshold. I'm not sure what happens in 2030. Every building seems to have us go down. So I'm wondering if it's something to do with the grid, if there's like some plant that's going offline at 2029 or 2030, because every single building we see this drop. But generally speaking, we assume sort of uniform emissions over time. We see this drop for everything in 2030. I'm not quite sure if that is, but then we see the penalty schedule for all the different years. So we see 2030 to 2034, we're still under that line there. And then 2035 to 2039, we're seeing about $37,000 in fines for this one building. And then by the time of 2050, if this building doesn't start to comply, it will have $250,000 in fines. So non-trivial, right? This is material fines for these buildings. It's a long way away, but that's a pretty serious penalty for anyone that's managing a building. Next slide, please. Okay, so here, while I mentioned it's only 3% of tax lots that are covered by Local Law 84, and the same figure applies to Local Law 97, there is some good news. So out of the 27,000 BBLs from the covered buildings list published by the Department of Buildings, initially matched with Map Pluto. I think the number, there's more, there's a couple thousand that probably didn't match initially, but most of them matched. If we sum those Map Pluto building area fields, we get 3.1 billion square feet. And consequently, that's 55% of the total building area square footage in New York. So 55% of the total building area, all the square footage in New York, is actually covered by Local Law 97. And that I thought was like really amazing, because I look at the number of lots that are covered, and it's pretty low. It makes me feel like, oh, this is not very comprehensive. But then when we look at all the square footage, all the activity space, indoor activity space, it's actually the majority of the square footage. So that's really exciting to me. And then by 2050, all of this square footage presumably will be net zero. So that's a pretty audacious goal. Next slide, please. And then according to the Department of Finance, the Division of Tax Policy and Data Analytics in New York City, the entire market value of fully and partially taxable property approached $1.4 trillion. Okay? So an approximate estimate, we're using some like back the napkin math here, assuming uniform value across square footage, not including vacant land value, across the geography of NYC, is that about $770 billion of building area market value in New York is actually covered and subject to emissions reduction requirements under Local Law 97. So again, this is like a lot of assets under management. There's a lot of fines there. I'm actually working on trying to calculate. I don't know if anyone has done this before. I've been doing a headless browser on that building energy exchange to calculate all the penalties. I'm sure I could probably create that formula myself, but I'm like lazy and like do hacky stuff like that. But I'm trying to calculate all of the penalties, right? And then we're going to try to like work with folks and show like a solar installer where's their addressable market, which will be all these buildings that need to retrofit. So if you're a solar installer, that's your like addressable market. That's who you're going to target to say, hey, like we know you have a fine coming up pretty soon. How would you like to have a consultation for solar arrays to be installed to the roof? And then while a lot of these improvements, almost all these improvements for buildings are going to cost money, New York City does have a program called NYC PACE, which is the Property Assessed Clean Energy program, which actually provides low-cost funding for energy-saving measures in new construction and renovations. Forget what CUNY department. There's some department that actually helps people navigate PACE program. And so this funding helps owners comply with local law 97. So if you want to do like a lighting, like low energy lighting adjustment, you can actually get different types of loans and things like that to help support those kind of initiatives. And they end up, the return on investment actually starts to be positive for some of these programs. So I think there's a lot of headwinds in decarbonization, as we can all kind of assess from the last couple of months. I do think it's important that we recognize the amazing achievements in New York City and this sort of like wholeness of local law 97. And then next slide, we're wrapping up here. Thank you all for bearing with me here. And as a final point, I want to thank every single person who has pushed for and helped facilitate open data in New York City. We didn't have open data at Crosswalk, and we didn't have the local law 84 data, and all the other cities didn't publish that data, along with our federal data. None of the stuff we do would be possible. So things like open data, which has been sort of on the chopping block in the federal government, it's a public good, and it's critical to doing some of the research and analysis to help inform us of what strategies we can explore to improve our world. So we have that digital twin of the world to kind of play around and see what these different scenarios can show us. And if we cut off the sort of faucet of open data, it prevents researchers and policymakers from doing those exercises. So thank you all very much. Happy to open up the floor for questions or comments. If there's anything that I covered that was like confusing or you want to dig in more, had to answer those questions, or maybe some questions I can't answer. I don't know all the sectors to a T, but yeah, thank you all. Any questions? Yeah.
On the point of federal open data, so it sounds like these models depend a lot on open data at federal level. Are you seeing issue with availability, or do you sort of have contingency plans for that?
Yes. So a lot of the data, I knew this, and his questions could come up because this is something we talk about a lot. There have actually been a lot of initiatives to archive data, and we've been a part of a few of them, like CJEST, Center for Climate Justice. I forget the actual acronym, but like we've been backing up a lot of the data. We got a lot of calls from our partners to like I got a call on a Friday night. I had the whole weekend. We were like backing up federal data, the GRAPES data set, which is somewhat similar to what we do, but is like a raster data set. It's sort of like a top-down emissions model. But so yeah, there's a lot of fear. One of our co-founders is a former EPA administrator, and like he kind of hears things. So we've been trying to back everything up. There's a couple data sets that get released annually, and I guess like, are they going to be released? It's a big question for us. And if, for example, power plants, EPA stopped having to have these power plants and high emitting facilities report, that would be a huge problem for us. Yeah. So, I mean, at that point, I don't know what our contingencies necessarily will be. We probably want to build models to sort of like forecast the data, which is really tough because like if we were looking at the sort of national trend, power plants open and close like fairly often. Fortunately, a lot of coal power plants have been closing, and that's like driving a lot of the major emissions reductions across the US. And I don't know how we know about those if the EPA data wasn't there. So we're very dependent on that. And if it goes away, we'll have to be very creative on what we do. Sorry, what was the second question? Okay. Yeah, anything else? Yeah.
Yeah, thank you so much for the talk. And funnily enough, I work for a company called Sidewalk Labs that is now part of Google.
Yeah.
So I just thought it was really funny. But yeah, I guess I'm really intrigued by the building emissions calculation piece. So Sidewalk Labs has this tool that's now in Google Earth, and so I work for Google, and it's like a real estate development, like geospatial design tool essentially for both retrofitting and creating like new build designs.
Yeah.
And so I'm curious if you've done any work or like exploratory work on like calculating building emissions for new builds, and if that's something that's like in your roadmap at all.
Yeah. What's because Google has they have a couple products. What are the
Called Dell. It used to be called Dell, but now it's becoming, it's like
And then there's like
Yeah.
Open Studio from NREL too.
Yeah, there's
Ah.
a couple
Yeah, and then
interesting ones. Yeah.
so it's sort of interesting because our hypothesis was to use when we're building out the statistical model, we were looking at the physical models. Some of the climate scientists that I work with, they're leaning more to like using statistical models. Because some of the, I don't know if it's RMSC, like some of the metrics, it was sort of surprising on some of the physical models, like where they weren't as accurate as one maybe thought. Maybe they didn't have the activity data or like the EUI. I'm not quite sure. I'm the wrong person to probably answer this question. But we have looked into a couple of physical models. But what we're kind of trying to do is use the statistical model to generate our estimates. It may be that we go back to a physical model, but Dell, it's Sidewalk Labs.
Yeah.
We'll have to look at, yeah.
Sidewalk Labs doesn't really exist anymore, but
Oh, it was acquired by Google.
Yeah.
Okay, yeah. Dell, yeah, I'll have to look into that. Yeah, I'll probably send that to my team. We had a bunch of climate PhDs, and they would probably take a look at that. I know NREL has an awesome data set. I forget what it's called. Comstock, ResStock, and then there's another data set that's on Amazon that they published as like tract level estimates for buildings. Doesn't have the actual lat long, but it goes down to the tract and it has a bunch of characteristics. And that's just, it sounds like it's a similar product. No, we should look at that. We're mostly working on trying to model the existing stock, but it'd be good to know your methods and things like that, because sure, our scientists will probably learn from that. Any other question there as well here? Yeah.
Yeah, hi. So it was really cool to see all the different sources that I have to work with. I used to work with a research group that focused on subnational unmet efforts, as expected, like private companies or state level. And one of the issues that we had were different of these disparate data sources contradicting each other, especially when you have like different agencies you could report to and self-reporting in different external groups. I'm just curious if that has been an issue for you and how you thought about after the data contradiction. Yeah.
I'm smiling at that because when I found out what our team does right now to be like a little bit more conservative on the estimation is if there's two conflicting sources, we take the higher emissions calculation, because like, we could be doing like, mean or median if there's like multiple or things like that, or trying to get a better measure of central tendency. But I learned that I think on the power plants and industrial facilities, that there are like multiple sources of data, and they like more often than not like don't really match up. And so that's one thing. Like what I think we should do is probably give like a probability distribution for each asset, and use like I don't know exactly which sources. And these are sectors. I know the on-road sector and airport a little bit better. So like power plants, for example, I'm a little bit less informed. But what we should do, and I think what the market is also looking for, is in physical climate risk. This is also the case. Folks don't want just a value; they want that probability distribution as well. So, so right now the model is taking like a more naive approach where it's grab the higher value of the two, which again is probably problematic. But I think that's sort of the solution in the short term. But we should. I don't know how have you rectified or dealt with that in the past?
Sometimes sometimes it's going from PDFs. So there's a lot of qualitative, like maybe there's a different methodology that was used. It's a very slow process. It's the short of it. So
a lot of utility data comes in PDF format too. So like I don't know if there was any talks this week on like extracting data from PDFs and things like that, but like I know a lot of people in the early days of open data, like, and there's still sources of data that we get are like tables on websites, and I don't know if we're trying to think if we're scraping from PDF on any of our stuff or not, but but there's a lot of different data sources, and they don't come in like super easy to use formats. It's just really quite annoying. So like one of the big trends in tech now, obviously, is that it is building bigger and bigger data centers to power AI. I'm curious, have you looked at like the emissions impact of those? Okay, first off, great question, because this is a hot topic. And then there's a guy, John Lippert at Chicago Tribune, who actually just put an article last week about data centers, and they impact. He also did an article we did with like Chicago, which is really interesting. I just want to make one quick point before I get to answer the question. In the city of Chicago, a lot of the largest emissions actually happen outside of the city. So there's places like Gary, Indiana, that have more emissions than the entire city of Chicago. It's just like insane to think about. But so this reporter who reported this article that we helped him do the data analysis on reported on data centers. So data centers are highly energy intensive. And there's been a couple studies where they drive up utility costs for all of the residences around them. We have not done a data center project yet, but I don't know if they have to report it. I don't know if they have to report to the EPA. That would be a good question. Bring it up for myself. I don't know if I can answer that question, but if they didn't report to the EPA, and we would be modeling them just as scope 1 buildings if they have on-site EGUs, and then scope 2 for all the power they might draw from the grid, because they're often located really close to power plants, right? Was there another part of the question? No. So we haven't done that, but it's like it is a huge topic right now, and I think a lot of small towns are having to deal with a data center coming in, and then they purchase they pre-purchase energy at like a lower price, and then actually they suck up a lot of the energy at the lower price. That will actually drive up the prices for some of the local residents. There was another question back here, and then I'm losing track a little bit. Yeah, go ahead.
If you do talk, do you also in your project changes in the energy grid, like in the mix? Because say in like the state of New York, we're gonna have our hydropower coming on, so like we're looking at kind of like what our Level 97 kind of like compliance will be down the line, right? So like, is that also a part of your estimate?
So we do some forecasting, but I think that assumes that the grid mix is what it is at the latest data we get. We get like data from the balancing authorities. And so I think we take that snapshot from the most recent balancing authority data. And then for our projections, I don't think we actually, in the forecast, I don't think we take into account those policy changes. I wonder if that's what actually drives down the grid for scope 2. That's probably
we're at stage 7.
Yeah,
there's gonna be some hydropower.
Okay, that probably answers my question. I haven't had time to look into that. So we don't do that.
You see that being a part of your money, friends?
Yes, in some way, we would like to be able to enable people to click on buttons and do different policy interventions. Imagine you could you're mayor of a small town, and you're like, I want to do like EV charging station, the policy, right? I want to do incentive or we're going to build EV charging for public use, and then be able to click a button and say, this will draw down the trajectory. Like it'll take the graph down. Unfortunately, we're not there yet. That's something we've been talking about over it's 9 of us. So we don't really have that much capacity. We're focusing right now on the asset level, which I think will allow people we'll start to build a sort of scaffolding for allowing people to do those kind of policy interventions. And I don't check me on time. So, okay. Is there another one to go on right now?
I don't know. I don't think so.
Okay. Question here and then there after there.
Just kind of related to the AI question. Do y'all use LLMs or AI at all? So
yeah, okay. This is a good question because we're very aware of the intensive energy use of data centers, but also there's this promise that AI can help us solve climate issues. And I always see that all these companies now with branding are like, oh yeah, AI is going to solve these complex optimization problems and things like that for us. Our modeling, mostly the only machine learning that really goes into our modeling is regression. We make decisions on data that are more search, heuristic based decisions. And then there are some like statistical regressions that happen if there's actually a good example of the reporting data or like where data conflicts is if the state like fuel use consumption differs from like some other, I'm now going to start get lost in the weeds where I don't really know, but there are some cases where we actually have to do some smoothing or some sort of capping of the data because it conflicts so greatly. So at the end of the model, there's some statistical regressions. That's all the machine learning that is in the model. It's mostly just this giant like hoovering up of data and like merging data, deduping data, and things like that. One of the things that we're trying to do right now is model building level emissions. We can't get all the building square footage data in the US. There's the NSI, but there's a lot of errors in it. So let's say there's a building's 3,000 feet. Somebody that works on the NSI says 30,000 square feet. What we have been using LLMs for, I have a grant through the Taylor Geospatial Institute and AWS to use large language models in addition to search agents. So basically thinking of like putting in a query to the web and like Google coming back with a bunch of responses to take those text responses and extract, kind of like what you were talking about before, using a Gen AI model to extract information from those queries. So it's like an agentic approach where you're like querying the web. It's like 100 Main Street. What is the square in I don't know, Utica, New York? What's the square footage of that building? And then it'll come back in the request parsed as like sort of human readable text, but it won't be in a structured data format. Then to use the LLMs or AI to help structure that data. So we are doing that in addition to looking at commercial providers. That's really the only use of like LLMs that we have. There's a lot of companies that are purporting to be able to solve a lot of the optimization problems on how to like what to target first in your emissions inventory to like what's those sort of low hanging fruit or different policies that you do. I haven't really seen that come close up. Yeah, good, great question. And like, I think there actually is a lot of promise for AI. Like I've been kind of amazed the last couple of years of
Yeah, like DeepSeek.
Yeah.
It's like emissions would like go up.
Yeah. So hopefully we could kind of bring that emissions and energy consumption down on these models. Yeah. Question?
Yes, in regards to, I already mentioned here about local law 33 in regards to the grading of the buildings. Are they using local law 84 to benchmark that? And if they are, what is the level of or ratio calculation they're using?
What is local law 33?
It's just the energy grading now. Buildings has to have.
Oh, the lead, the pose, yeah, the other area.
So that was curious to see like what is the benchmark they're using and what is the level of emission they're using to calculate that.
Yeah. Who is the NY? You worked on the NYU stuff. Do you know the answer to this? I don't know.
I don't know how 84 is the 33, but
Your benchmark and 30.
It's like the letter.
That's what I don't know. You have to think.
yeah, 84 informs 30.
Yeah.
Okay.
And I was wondering, like, what is the level of emission calculation they're using? What variables they're using to calculate?
I don't know. Yeah, I'm sure it's in the. I haven't looked at local law 33. I'm sure it's in the language of the law or something like that. But it's EUI. It's probably the comparison in that old chart where we had like the average for that type of use of building. So what you do to compare or benchmark would be not to just look at your overall emissions, but the emissions like per a similar type of building with a similar type of square footage, that EUI ratio, I guess, or how does your EUI compare to the standard EUI? And I think that's where the letter grade has come. But don't quote me. I would say go on one of those like PDF. Well, actually use AI to like read the PDF. Yeah, yeah. I've done building benchmarking for my building, and that's basically they give you an energy grade from 1 to 100. Or I get a score from 1 to 100. That's based on that kind of like normative comparison, and that determines your letter grade. Yeah. It's like the with the restaurant one or whatever. Yeah. Cool. Well, is there any more questions before we wrap up? Yeah.
Yeah, I have a quick question. So with these clients that you work with, these cities they work with, when they use your data, do you see them? Are you seeing more cities or more municipalities adopting like a similar local law 97 policy?
Yeah, I was actually quite. Oh, the 97 you said.
Yeah.
Okay, yeah. So, I was surprised how many are doing like an 84 like,
Yeah.
benchmarking. I don't know of any other, and somebody can correct me because I am not I started learning about this very recently, or in the last like few months, I'd say. I have not seen as many penalties like local law 97. I have seen there's like 65 or more cities that are doing the benchmarking. The penalties, I haven't seen anything come online for any other cities.
I think Boston.
Yeah.
do it.
Yeah, Boston is pretty far ahead. Are there other cities that you've heard of?
Yeah. Oh yeah. There's like I think Denver has one, Washington State had one, DC has one.
Okay.
I have like a theory, and it's not really proven yet, but any city or municipality that starts with an 84 law eventually evolves into a bullying set.
Yeah, you have to measure. You have to measure it first. Yeah, because otherwise you wouldn't be able to implement the penalties. Yeah. Any other questions? Oh yeah.
So I imagine you're just picking data sets that you have like complete data sets for the whole US or the whole, is it global or is it?
Right now, it's just the UX. Yeah.
So like, I guess, are there like opportunities for when you have somewhere like New York where there's a lot of extra data to like be able to fill in the gaps in other geographies?
Yeah, this has been a sort of interesting thing is like, because where there is like, we're using other cities' data to do our to help build our model. But we're gonna apply that model like across the US, which probably a lot of bias, to be honest. Like the difference between buildings, the parts of the US, like there might be large swaths of the US where we're not capturing things. We are including like climate zones and cooling degree days and heating degree days, things like that for all of the buildings in the US. But as far as like some of the other sectors and things, we haven't really, like, if we can get higher precision or like maybe even better accuracy by using local data, we haven't really done that. Like the one thing we want to say is it's apples to apples. When you do a inventory report in Bangor, Maine, and then you do one in Mesa, Arizona, it's sort of apples to apples comparison, which is, it's one of the things that helps our climate mayor cities, but it, for commercial customers, doesn't really help that much. So, yeah, it's an interesting thing because we want to keep it uniform. Because also want to make.
We never had this in our sub-on record.
Oops. Okay. With that, well, thank you all for joining. I appreciate you all attending. Thank you.